In this video, we'll be talking about rate laws. A rate law quantifies or gives a mathematical expression for the relationship between reactant concentration and the rate that a reaction occurs. Note that this is only the concentration of the reactants, not of the products. And so this is going to give us a mathematical relationship. So let's choose my favorite reaction. So potassium chlorate is going to react with sugar to form carbon dioxide, water, and potassium chloride. This is the dancing gummy bear reaction. All right, so we could choose to define our rate based on how we're going to measure our reaction. And so we might make a logical choice on how to define our rate. For instance, here I've written it as the disappearance or the using up of that concentration of sugar from the gummy bear, which is why it's negative because it's disappearing, with respect to time. So negative change in sugar concentration divided by the change in time. And remember that we could always convert, once we know the rate of one reactant or product, we can always convert to the others using our relative rate laws or our balanced reaction. So this rate law is going to have a rate constant, which is always denoted lowercase k, times the concentration, and this is an initial concentration. So what we start the reaction at usually, so the concentration of potassium chlorate, which is our first reactant, raised to some exponent m. And so this m represents the order with respect to the first reactant, which in this case is potassium chlorate, times the concentration, and again here usually the initial concentration, of sugar raised to this exponent n, which n is going to be equal to the order of the reaction with respect to the second reactant or sugar. If we have more reactants, we'll also have, each one of them will have some exponent, and you can give that whatever letter you want, whatever letter you're comfortable with. And so m plus n, the sum of those exponents, or however many exponents we have, will be the overall order of the reaction. So if n plus n equals 2, then we have a second order reaction. So we'll talk a little bit more about orders of reaction as we go through our study of kinetics. So how can we know the rate law? How do we determine a rate law of a reaction? Unfortunately, we can't just balance our reaction and look at our balanced reaction and intuitively know the order. The order of reactants is not going to have any correspondence to our stoichiometry coefficients or our balanced reaction. So unfortunately, or fortunately, depending on how you want to look at it, we will always have to measure the rate law of a reaction. So we'll have to take some sort of series of measurements in order to determine this mathematical relationship. So we're going to talk more about the most common method, which is our initial rates method, in a future video.